Now, a really good question that you might have here, because we haven't talked much about fields in physics, is, well, what's an electric field? That's a very good question. So electric fields are things that exist everywhere in space. So this little thing makes an electric field everywhere in space. It will create an electric field. The electric field is a vector. So everywhere in space, it exists, and it has a strength, a magnitude, and a direction. You can kind of guess maybe that if I get really far from my acrylic rod, it is probably very weak, a very small electric field. But if you get close, it's probably a big one. And then the direction is something that we'll talk about as we develop this model. Most importantly for this week is that an electric field tells an electric charge what force to feel. So here again is my electric charge, here is my electric field, and it's going to tell the pith ball what force to feel. And the size of that force is going to be given by the amount of charge on the little pith ball, the test charge is what we'll often call that, times the strength of the electric field that this thing creates. And you can see that the electric field is going to depend on space, depending on how close I bring this to the source of the electric field. I'm going to get a different amount of force, which means that I'm going to have a different amount of electric field depending on where this charge is located. All right, so those are kind of the basics for how charge and electric field work.